All right, now that we've looked at linear relationships in a table and a graph, what we're going to do now is we're going to look at proportional linear relationships, okay? So something just a little bit different, all right? So proportional relationship, what we need to understand is this. In a proportional linear relationship, it's going to be two quantities, which is A and B, that have a proportional linear relationship if they have a constant ratio and a constant rate of change. Notice that two things must occur in order to be a proportional linear relationship. Whereas before, in a linear relationship, you really only needed to see that pattern on the table or on the graph, okay? In a proportional linear relationship, it not only must show that constant rate of change, but then it has to show a constant ratio, okay? And then we use symbols. Typically, B over A is a constant ratio, and then change in B and the change in A is a constant, all right? And then we know that as the constant rate of change, okay? You could refer to this as the change in Y over the change in X if you're looking at a graph standpoint, okay? So let's go ahead and look at an example, all right? First example I'm going to have here is I'm going to look at, is there a proportional linear relationship between the degrees Celsius and the degrees Fahrenheit, okay? So that's what I'm trying to determine here. So with Fahrenheit going to be my Y value and Celsius going to be my X value, okay? So I have my table here. I know that at 0 degrees Celsius is 30 degrees Fahrenheit, 5 degrees Celsius is 41 degrees Fahrenheit, and so forth. So again, what I'm going to do is I'm going to look and see, okay, what is the constant rate of change for the degrees of Celsius? So this went up by 5 here, and this went up by 5 here. So from 10 to 15, that also went up by 5. And then from 15 to 20, that also went up by 5. So because I saw each of these go up by 5, each of these down here below better go up or down by the same amount also, okay? So from 32 to 41, that went up 9 degrees. So in order to be a constant rate of change, and to be a linear relationship, these two, this has to be 9 also. So from 41 to 50 is 9, so yes, it does fit that one. Does this one fit up, go up by 9? Yes, it does. And does the last one go up by 9? Yes, it does. So the table checks out. So when I look at this, I can see that yes, there is a constant rate of change. The constant rate of change is 9 degrees, or change in Fahrenheit, over the change in Celsius, that would be your B and your A, okay, is 9 over 5. Okay, so that checks out. So the change in B over change in A is a constant, okay, because it was the same in each time. What I need to do now is I need to figure out the ratio. The ratio is just a little bit different. To find the ratio, what we do is we take the Y value and we divide it by, or write it to the X value, okay? We won't use 0. We're just going to use the next one. So we're going to use 41, because that's the Y, or the B, okay, over A, which in this case is 5. And I'm going to use a calculator. I'm going to take 41 over 5 to find that ratio. 41 over 5 gives me 8.2 as a ratio. Okay, I figured that out by taking 41 divided by 5 on my calculator. So I'm going to pick the next point, which is 50 and 10. And I'm going to take 50 and I'm going to divide it by 10, or 50 over 10, because again, this is my B over A as a ratio. 50 over 10 gives me an answer of 5. All right, and just so I'm going to check one more point, which I really don't need to now. I'm going to take 59 over 15, and it gives me approximately 3.9, okay? What I notice is this. When I did the ratio of the Fahrenheit to Celsius, I got 8.25 and 3.9, which means this is not constant, because in each time it changed, okay? So because it changed each time in the ratio, this is not a proportional relationship. So not a proportional relationship, a proportional linear relationship. So even though I graph this, and this would form a linear relationship. It is not proportional because the ratios are not all the same. Okay. So this weekend I went shopping, trying to get prepared. They had Fairway had a great deal on green beans, and our household loves green beans. So I'm going to create a table here to show you kind of what it looked like. There was the number of cans, which was my X value, over the price that we paid for the cans, okay, which is going to be the Y value. All right. For 0 cans, I paid $0. All right. For 5 cans, I paid $2. For 10 cans, I paid $4. For 15 cans, I paid $6. And then for 20 cans, I would have paid $8. Okay. So again, what I want to do is I want to determine, number one, is there a constant rate of change? So I'm going to look at the table, and I'm going to look and see if I see a constant rate of change. So that went up by 2. This went up by 2. This went up by 2. And this went up by 2. So I noticed that each of these changed by 2. So in order to be a constant rate of change, these also must go up by the same amount each time. They don't have to go up by 2, but they have to go, these numbers all have to be the same. So from 0 to 5 is 5. From 5 to 10 is 5 also. From 10 to 15 is 5. And from 15 to 20 is 5. So yes, they do have a constant rate of change. As the number of cans went up by 5, the price went up by $2. So I would write that as price over number of cans. So my thing would be $2 for every 5 cans. Okay. So now what I want to do is I want to determine, hey, is there a ratio? So is the B to A a constant ratio? So how I do that, again, I do it like just like before. I take my Y value, I put it on top, and I'm going to take my X value and put it on the bottom. So notice that I have 2 and 5. I'm going to do 4, and I'm going to do 10. I'm going to do 6 and 15. All right. If this is a proportional linear relationship, they will all get the same thing. And so when I take 2 divided by 5, I get 0.4. When I take 4 divided by 10, I get 0.4. When I take 6 divided by 15, I get 0.4. As a result, because we have a constant rate of change and each of the ratios are constant, this is a proportional relationship. So the number of cans and the price that I pay is a proportional relationship in this problem.